Hey guys, welcome back. In this video, I'm gonna cover the problem unusual queries, which is held in Starters 137 Codechef on 5th June. So let's jump into this problem statement, and later I will cover you the the solution part of it. So basically, let me just read it. It says that you are given a three integers n, a, and b. Further, it is known that mod of a minus b is less than or equal to 1, which means that mod of a minus b is less than or equal to 1. Mod is an absolute value which is always positive. So the positive value is less than or equal to 1. So the maximum possible cases are either 0 or it should be equal to 1, and there are no other possible values since mod of a minus b will be giving that. So either you can equate a minus b equal to 0 or a minus b equal to 1. If you do a minus b equal to 0, then a will be equal to b, or a minus b equal to 1, then a will be equal to b plus 1. So there are two possible cases we can derive it from here. Next, it says that count the number of integer x, count the number of integer x such that x lies in the range 1 to n, and this is also positive, but it starts from 1 and it goes till n, and we are getting the n in the input parameter. And it says that there exist non-negative integers p and q satisfying the equation a into p plus b into q equal to x. I see. And we need to find the number of integer x such that this equation is satisfied. So see, what it's saying is a into p and q, it doesn't matter, and that why? Because these are non-negative integers. Non-negative in the sense it cannot be negative, it can be 0 or it can be positive. So it can be anything else. It can become, this cube can become 0, a into p can be equal to x, or p can become 0, b into q is also equal to x, like that also it can become. So the problem is easily simplified. We can make one of them 0, we can solve the other one, and something like that. But this x is not constant, but this x goes in the range 1 to n. So we need to find the number of such integer x which this equation is satisfied or possible. Let us see the input parameters. We are getting the test case t, and next line we are getting any a and b. That's it. So that's the problem statement. Now if you jump into the solution code of it, so initially we are getting the three integers n, a, and b, and the first most possible case, as I told, a can be equal to b, right, or a can be equal to b plus 1. And since we derived from this modulus value, how I told, I will repeat, modulus of this thing is less than or equal to 1. So something positive is less than or equal to 1. It cannot be, it can be a minus b can also be equal to minus 1. And yeah, so there are three possible cases: 1, 0, minus 1. Right, there are three possible cases, not two. A minus b can be of three possible cases. A minus b can be equal to 0 if it is such that a will be equal to b. If a is equal to b, if a is equal to b, then what will happen? We can take a common outside, and it will become p plus q, and which is equal to x, right? P plus q is equal to x. So these are p and q, it doesn't matter, it's on our choice. Then we can make p equal to q, or q is 0, then it will become a into p as x. If it is like that, and if it is like that, then what is the maximum number of x, number of integers the x can take to solve this equation? If then maximum value of x we need to put as n, then p will be equal to n by a. If q was 0, and then q was 0, a into p equal to n, how will you solve for p? P will be equal to n by a. That's how we will get this first corner case, if a was equal to b. Or else if a was not equal to b, as I said, there are three possible cases: minus 1, 1, and minus 1, 0, and 1. 0 we have solved here, 0 we have solved here, And next, if we see, if for the a minus b was equal to 1, then a will be equal to a will be equal to 1, then a will be equal to b plus 1, right? B plus 1. If it is minus 1, if it is minus 1, then a will be equal to b minus 1. So a can be of any of this possible. A is just greater than b by 1, or a can be just less than b by 1. So if it is like that, now if a is lesser than b, a is lesser than b, then it is of no use. Why? Because the x is determined by the maximum coefficient of the linear equation. So just get the maximum of a and b and store it in here. If compare a and b, if a is less than b, then store the value of b to a. If a is more than b, well and good, keep the value of a as it is. And after swapping that, we need to run the binary search from 0 to a minus 1. And after running the binary search, find the result by same how we did for a equal to b as n by a. Do that into we will be getting the L and R as equal to some middle position, that position plus 1. And then we need to compare the value. If what if the remainder we are getting by the dividing the maximum value of x by a to that middle position, and if we add that value, and then now total number of possible cases are 1 2, x can go from 1 2 3 so on till n. Just add the all the x can be 1, x can be 2, x can be 3, x can be 4. So just add the all the cases, and summation will result out to n into n plus 1 by 2, n into n plus 1 by 2. Subtract that and print out the result. That's it. So it was so simple, and that's it. If you do that, even the corner cases of the large constraints can also be solved. So thanks for watching this video. Bye.